Alright, so 7.1, this is what your first page of your note package should look like. I know there's an activity page, but ignore that for now. We're going to do that in class. So for 7.1, you should be looking at this page as we go through it, and then we'll go through the examples as well. Alright, so for 7.1, we're talking about polygons and parallelograms. We're going to be able to name and identify all the different kinds of polygons and stuff like that. So first off, a polygon is a plane figure that is formed by three or more segments called sides. Each side intersects two other sides at the endpoints. The endpoints are called vertices or vertexes. So in this polygon we've got a side, a side, a side, a side, and a side. So there's 5 sides, and each side is connected at an endpoint called a vertex. Okay. The intersection of any two sides of a polygon, that's the vertex. We talked about it. The vertices, pluralizing it. All right, so the diagonal, this one is important. Oh my goodness, moving stuff around. The diagonal of a polygon is connecting any vertex to a non-adjacent vertex. So RS here is a side, but RT is a diagonal, and RP would be a diagonal, and RQ would just go back to being a regular side. So this one actually has 2 diagonals from R to T and from R to P. So that number of diagonals connect vertices that are not adjacent. Alright, so a 3-sided shaped figure is called a triangle. You should know that one. 4-sided is quadrilateral. 5-sided is a pentagon. Notice the agon. This part right here is important, the agon part. Pentagon, hexagon. Notice the agon part. We're going to go through heptagon, octagon. You should know that from stop signs as a child in elementary school. A nonagon is a 9-sided. Nonagon. A 10-sided is a decagon. If you think about like a decathlon, that's a 10-event race of some sort. So a decagon is a 10-sided shape. 12-sided is dodecagon. And if we don't know how many sides there are, let's say it's 11. There's no name for an 11-agon. So that's exactly what we call it. We call it an n-gon. So it's an 11-gon. 13-gon. I call them agon, like 13-agon or 14-agon. So that's kind of how we name different polygons. You'll need to memorize these. They'll be on the test. All right, so let's talk about the concept of convex versus concave. Okay, a polygon is convex if no line that contains a side of the polygon contains a point on the interior. Notice how each of these sides, if I extend them out further, this line never touches the inside of the shape. Not a single one of them does. Okay, I always think of it as they're pointing out. All the arrows are pointing out. Now, if I look at this one, notice how this side length here, if I connected this arrow out, it would cut right through the middle. That makes this one concave or non-convex. Okay, concave. If you think about a cave, how it's kind of got it's an innie inside of the cave. It's not a very good looking cave for this one, but anything that has an inward shape is a concave, or it's not convex. So if you extend out any side length and it cuts through the middle of the shape, then it's concave. Alright, so if all sides of a polygon are congruent, then the polygon is equilateral. Notice how we call an equilateral triangle? Well, we can have equilateral quadrilaterals. Those are squares and rhombi. You can have an equilateral pentagon, an equilateral hexagon. All it means that it's the same sided. Okay, equiangular, same idea. We can have an equiangular quadrilateral. That's your rectangles and your squares. But you can also have equiangular hexagons, polygons, nonagons, 13-agons, whatever. Now, if they're both equilateral and equiangular, then it's called a regular polygon. Get familiar with that term regular. Because if I give you in a question that polygon ABCD is regular, then I told you that it's ABCD, that's four-sided, and I told you it's regular, which means it has equiangular and equilateral. That makes it a square. So I'm going to use tricky wording like that to make sure you know the vocabulary, like equilateral, equiangular, and regular. All right, so the polygon interior angle theorem. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. Interesting. The measures of each interior angle of a regular n-gon is... Oh, this one's if it's regular. So this adds the regularity, and if they're all equiangular, then we can divide it by how many there are, and we can get the individual angle. This one just tells us what they add up to be. Okay, the sum of the measures, right? But if it happens to be a regular polygon, then we can say that they actually, if I divide it by how many sides there are, or angles there are, we can then determine the actual value of each angle. So polygon exterior angle theorems. Now we're looking at exterior versus interior. These were our interior angles we talked about, and each of these adds up to be the previous formula, n minus 2 times 180 over n. Okay. But now if we look at the exterior angles, if we extend out the line segments in a pattern, see how I'm extending all these ones out one at a time? Okay. So then the sum of the measures of the exterior angles has to be 360, which I find fascinating. And again, if it's a regular n-gon, then we take that 360 and divide it by how many there are. And this exterior angle here, this number 1 right here, if this is a regular pentagon, I take 360, I divide it by 5, and I should get like 62 or something like that. And I end up with 62 degrees for all of these values because they all add up to be 360. No, I think it's 72. Anyways. So, yeah, that's the exterior angle theorem. A parallelogram. There are 6 different ways to define a parallelogram, but the most basic way to prove it, or to say it's a parallelogram, is to say that both sets of opposite sides are parallel. This right here is a parallelogram because the top and bottom are parallel and the left and right side are parallel. That guarantees you a parallelogram. There are 6 other ways to talk about it, and we're going to talk about this is just the first method. Okay. So now we're going to get into some of the different ways of defining them, and we're going to get to some examples. So a parallelogram is a quadrilateral both, yes. Turn to page 3, it's an actual text question. Just a recommendation. You'll see it when you get there. Okay. Parallelogram. Quadrilateral with both pairs of opposite sides. Actual test question. Based on the definition, using symbols, state what angles or segments must be congruent or parallel segments. Oh, this bottom part down here? This is a lot of test questions, actually. I'm going to ask you that a bunch of times. So I'm going to give you a definition, like up here, the opposite sides are parallel. And I give you the definition, and you have to tell me, using symbols and letters and whatever, state what angles or segments must be congruent or parallel segments. So based on this definition, I've told you that both pairs of opposite sides are parallel. So the test question, I'm going to give you this statement up here. I'm going to ask you to tell me information about this picture in symbols. So you're going to say that DC is parallel. It's a terrible parallel. My apologies. Well, let's see if this works. I doubt it will. Nope, didn't work. Parallel to AB, and you'll say that AD is parallel to BC. That's the information that you get off of this definition. Okay. So, yeah. It's going to be like that on the test. You also have to diagram it. So I would say, like, to get my little pointer thing going here. I'd say parallel to parallel and double arrow for double arrow for parallel. So you have to mark your diagram. You got to tell me it in words and symbols, those types of things. There you go. So this is what I would expect on the test question. Right here. You marked your diagram. You wrote out in symbols. Yes. Okay, don't have time for questions. So if a quadrilateral is a parallelogram, now notice I'm telling you it's a parallelogram. If I tell you it's a parallelogram, then you automatically know that the opposite sides are congruent. Okay, this goes both ways, but this is a second method of proving that that's a parallelogram. Okay, so if I have a quadrilateral that is a parallelogram, the opposite sides are congruent. So again, test hint. If I give you this definition, can you tell me information about the picture? The information that you should have is that they're congruent. I already marked the diagram for you, but you need to be able to write out it in symbols. So we mark the diagram, AD congruent to CB, and then we say that DC is congruent to AB. So this would be the answer to this test question. I give you the definition, and you tell me information about that definition and mark the diagram properly. All right, so now we're on to our first example. So find the value of the variables for the following parallelogram. Notice, I'm telling you it's a parallelogram, okay? So if it's a parallelogram, then we've already learned that the opposite sides must be congruent. If that's the case, that means that 5 is equal to P. Good. And 6 is equal to Q minus 3. So if I set that up here, I say P is equal to 5. Why is that true? Well, that's opposite sides are congruent. That's the definition of the parallelogram we're using. And then if I say that Q minus 3 is 6, that's the same thing as opposite sides are congruent, and then I do a little addition property of equality, and I'm done. You will have problems on this test, just like this. They should be easy. They're meant to be. Okay? So just remember, opposite sides are congruent, and you'll be fine. So now, more information, a new way of proving that they're a parallelogram. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Notice how these angles are opposite from each other, and they're congruent. 2 arcs for congruent here, single arc for here. So this is the third method. Okay, you got to be able to show me symbols and mark the diagram. So I give you this picture here, and I say it's a parallelogram. Well, you've got to be able to determine which of these angles are we talking about. Notice how opposite angles doesn't mean alternate interior angles. That's not what we're talking about. We're talking about opposite angles. We're talking about completely the entire shape over here and this one over here. So angle K and angle M are congruent because it's a parallelogram. Now notice I said M and K, but that might leave some confusion based on this picture. So I would say JML and JKL. That's the specific angle I'm talking about. Now I also look here and I say angle J and angle L are congruent. So I mark those. But again, there might be some confusion. So I mark it as KJM. Notice I said KJM. That's the angle I'm talking about, this whole big thing. And I say that's congruent to KLM. So that's the next way to prove it. Here's a new one. Okay. If a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So we had opposing angles. Now we have consecutive angles. So that means that P and Q are supplementary. Supplementary meaning they add to 180. Q and R are also supplementary. R and S, S and P. Any set of consecutive angles must be supplementary if it's a parallelogram. So this is your fourth method. Let's look into it. Let's see if we have a test question just like this. I give you this definition. You've got to pick an angle. Looks like I picked S here. And I say, all right, Write the measure twice, MSR. The measure of PSR. My apologies. And then I write it twice. And I say PSR plus SRQ has to equal 180. But also SPQ also has to add to 180 because angle S here, or PSR, has two consecutive angles. It has angle P up here and angle R over here. So I want to write both of those as being added to equal 180. Okay? And set both sums equal to 180. Now what's great about this is that if I give you variables and things, you'll be able to just set up, okay, this plus this equals 180. This plus this is equal to 180. And then we can use the transitive property and get rid of the 180s and set them equal to each other. There's lots of cool math we can do once we get to that point. All right, so find the variables. This is example 7.2. Find the variables for the following parallelogram. Well, if I say that it's a parallelogram, then I know that the opposite angles are congruent. So I say that their opposite angles are congruent. I also know that the consecutive angles have to be supplementary. And then I do some subtraction property, and I got my answer. Okay, you will have a problem on the test with the same level of difficulty as finding A and or B above. So you're going to see a test question just like this, or the same level of difficulty. Okay? Hopefully you guys are comfortable with these already. So now we say find the value of the following parallelogram. So I'm telling you it's a parallelogram. So notice the opposing angles must be congruent. But I got this blue arrow pointing here because I want you to notice that this has a T and this has a T. Okay? I try and isolate the one that only has one variable. R and S, I can't really solve for any single variable. There's too many variables. But if I set it up as 3t minus 15 is equal to 2t plus 10, I can solve for that. I can get all my t's on one side, I can add 15 over, and I can get t equals 25. So I just solved for t. Now, if I notice that they're consecutive angles, 2t plus 10 and 4r, those are consecutive angles. Therefore, they have to add to be 180. So I put my answer here. Consecutive angles are supplementary. I substitute my 25 in for t. I order operations, I multiply, I combine like terms, I subtract 60 over, I divide by 4, and end up with r equals 30. Okay? So all of this was just the algebra portion down here. With that completed, I come over here and I say, well, now I've got opposing angles 4r and 3s. Those are congruent to each other because opposite angles are congruent. Now I substitute in my 30 that I found for r and end up with 3s equals 120. I divide 3 over and I get s equals 40. So I was able to solve for all those variables because I first isolated the single variable, and then I did consecutive angles, and then I did opposing angles. Not too shabby. Oh, I like this one. 7.4. Find the value of the variables for the following parallelogram. Okay, so I've got to find D, C, and B. Notice, again, I look for the single variable. B minus 10 and B plus 10. Well, that's got to add to be 180. So I come up here and I set them equal to 180. I combine like terms. I divide by 2. And then I get B equals 90. Well, with that, I can plug that back in, and I can find the value of C. Notice how B minus 10 and C are opposing angles. So I set them equal to each other because opposite angles are congruent. Well, when I do that, I can now solve for C by plugging in my 90. I substitute it in, I combine like terms, and I get C equals 80. Now, I've got some different options now. I can use C to find D, or I can go opposing angles again and get D, oh geez, There we go. And get D equals B plus 10. Well, when I do that, I get the opposing angles are congruent. I substitute in my answer, and I get to combine like terms to get D equals 100. So I just solved for D, C, and B. Again, I did the same thing. I isolated my single variable. I just want to get my B's solved for first, and then I can worry about C and D later. All right, so here's our new method. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Don't forget bisect. Cuts in half. Cuts in 2 equal pieces, like our 6-inch sub. Okay. This is the 5th method that we're going to learn today. So when we talk about bisecting, you're going to get an actual test question where I'm going to give you this picture, this definition, and you're going to have to mark the diagram and tell me some information. So I look here, I say diagonals bisect each other. Well, if they bisect each other, then the diagonals cut each other in half. So I mark the diagram. I say, okay, these two are equal to each other. Well, let's put that in symbols. I say AF is congruent to, my computer just broke. There we go. AF is congruent to FC. But also DF is congruent to FB. So this would be the answer to the test question. I give you this definition, I give you this picture, and I ask you to tell me some information off of it. So find the value of the variable for the following parallelogram. Notice here we have the diagonals are crossing each other. I told you it's a parallelogram, so you know that these two pieces are equal to each other. You also know that 8 and m are equal to each other. So I set this up. And I say, well, 8 equals m. Why? Because the diagonals bisect each other. And I say that 4k plus 11 equals, or sorry, k plus 4 equals 11 because the diagonals bisect each other. So then I subtract 4 from both sides, and I get, k equals 7. What's important is you understand that the diagonals bisect each other of a parallelogram. So again, find the value of the variables. If I drag this down a little bit, there we go. Okay. So looking at this, I notice I have a single variable here, so I could do these two are equal to each other, or I can do the top is equal to the bottom. Either way works. So if I look at this as v over 3 is equal to 6, I've got to get rid of this division of 3. So I say diagonals bisect each other, and then I multiply both sides by 3, and I end up with v equals 18. Great, I solved for v. Now I'm going to solve for u. I'm going to set both of these equal to each other, and my reasoning is going to be diagonals bisect each other. Okay. Once I do that, I can subtract 2u from both sides. I can add 10 to both sides using the addition property of equality. And then I can divide both sides by 3, and I end up with u equals 4. Again, this is just the algebra portion. The new stuff is the diagonals bisect each other. Okay. You will have a problem on the test just like this. Okay, you've got to be able to solve for u and v. Diagonals bisect each other. All right, so now I'm going to throw in a curveball here. Notice I told you it's a parallelogram, but I'm not asking you for this entire angle. I'm only asking for this top piece. Okay, and I'm only asking for this bottom piece. Are those two pieces congruent? Yes, they are, and the reason for that is, notice how I have parallel lines cut by a transversal, and I'm looking at the top one and the bottom one. This is alternate interior angles. They're inside the parallel lines, they're on opposite sides of the transversal. Alternate interior angles. Oh, man. So, since they're equal to each other, I got the same thing with 7y and 56. I divide both sides by 7, and I get y equals 8. Now, it's the same reasoning for why these two are equal. So I say alternate interior angles again. I subtract 2x from both sides. I add 38 over. I divide both sides by 7, and I get x equals 6. The curveball here was noticing it was alternate interior angles. Okay? So, summarize what you learned today. And let's talk. On Saturday, you'll have last chance to retake the Chapter 7 test. We'll talk about that, which Saturday we're talking about. You can come in on Saturday. You can take the Chapter 5 test if you want to retake it. It'll be your second chance at Chapter 5, not your third, but that's okay. Also, you can come in during lunch or whenever you want to. Here's a look at kind of what we're planning for the calendar. Monday when we get back, we'll do 7-1, 7-2, 7-3, 7-4, 7-5, right in a row. And then instead of going straight to the test, we're going to take 8.1 here for the pep assembly because it's short. And then we'll test on Chapter 7 on Tuesday. So this might get you a little mixed up. So be aware of what's happening. And don't lose all your Chapter 7 information just because I'm doing something different. Let's take a moment to come over here and look at your note packet. Okay. So we covered all of this stuff. We did all the examples. Hopefully they're the exact same as what we did in... Yeah, these all look the same. Okay. That was just like the last one we did. You summarize your stuff. Okay. Note packet looks great. I'm going to start a new video for your homework. Do your notes, do your homework.